The history of life on Earth is a grand book, written in stone and time. Most of its pages have been torn and tattered, leaving only fragments, incomplete fossils. But sometimes, in a few special places in the world, nature has accidentally sealed a few pages perfectly. These places, which paleontologists call by the formal German term Lagerstätte, are treasures, windows looking directly into a lost world. And perhaps, none is stranger or more fertile than Mason Creek. On a scorching summer day in 1958, under the harsh sun of Illinois, USA, the Mason Creek area did not look like a paradise. It was a ravaged landscape, a scar on the earth left by decades of strip mining for coal. Deep open pits alternated with giant heaps of gray shale, looking like the misshapen pyramids of a fallen industrial civilization. The air was thick with the smell of damp coal and baked clay. To most people, this was a wasteland. But to a special group of people, this was the promised land. Francis Tully was one of them. He was not a formally trained paleontologist from a prestigious university. He was a pipefitter, a man with hands calloused by labor and a burning passion for what lay deep underground. Every weekend, Tully would drive to Mason Creek, not in search of gold or diamonds, but for something far more precious, fragments of a distant past. He was an amateur fossil collector, but his patience and keen eye could rival any experts. He knew what to look for. Not giant dinosaur bones, but small, oval-shaped siderite nodules. Looking no different from stone potatoes, these nodules, formed from mud and iron minerals, were natural coffins. Inside them, protected from the ravages of time, were the delicate creatures that had lived in a tropical estuary more than 300 million years ago. Tully's work was a ritual of patience. He would wander for hours under the sun, his eyes scanning the ground, searching for nodules of the right shape and texture. When he found a promising one, he would pick it up, feel its weight, and then, with a practiced tap of his hammer honed over thousands of attempts, he would split it in two. Most of the time, there was only rock inside. But sometimes, a miracle would happen. The nodule would split perfectly, revealing a positive and negative impression of a long-extinct creature. Usually, they were familiar fossils, an exquisite fern leaf, a tiny shrimp, or the ghostly silhouette of a jellyfish. Each find was a joy, a direct connection to an ancient world. But on that fateful summer day in 1958, Francis Tully found something entirely different. He picked up a nodule. It was nothing special. He placed it on a larger rock and took out his hammer, a decisive tap. The nodule split in two, and Francis Tully became the first human in history to see an unbelievable creature. It was unlike anything he had ever seen, read about, or imagined. It was not a shrimp, not a jellyfish, not a fish. It was something else. It had a soft, torpedo-shaped body, a few inches long. At the front, a long, slender proboscis extended, ending in a pincer-like structure with a row of small, sharp teeth. At the back, it had a pair of triangular tail fins. But the strangest feature, the feature that defied all classification, was its eyes. They were not on its head. Instead, they were at the ends of a rigid horizontal bar that stuck out from the sides of its body, like a tightrope walker holding a balancing pole. Tully stood there, stunned, the nodule in his hand. The wind blew across the shale heaps, carrying the silence of 300 million years. He stared at the fossil. His brain, familiar with the forms of life on Earth, was trying in vain to find a classificatory drawer to put this creature in. But there was no drawer. This creature seemed to have been designed by a drunken committee of evolutionary gods. It was an absurd combination of body parts. He muttered to himself, a simple yet profound question that would haunt paleontology for more than the next half-century. What the hell did I find? Knowing he was holding something far beyond an amateur's understanding, Tully carefully wrapped his discovery and made a pilgrimage to the Mecca of Midwestern paleontology, the Field Museum of Natural History in Chicago. He wasn't just carrying a stone. He was carrying a riddle, a biological anomaly sealed in rock. At the museum, he sought out Dr. Eugene Richardson, the curator of invertebrate fossils. Richardson was a seasoned expert, a man who had spent his life studying the strangest life forms of the past. He and his colleagues gathered around a desk where Tully had carefully placed the two halves of the nodule. A hush fell over the room. Expert eyes stared at the fossil. Initial curiosity quickly turned to confusion, then to utter astonishment. They tried to compare it to what they knew. It had faint transverse lines. Perhaps it was related to worms or arthropods. But it had no exoskeleton. Its proboscis was somewhat similar to that of some worms, but the eyebar was completely unique. Perhaps it was a strange mollusk, a shell-less sea slug. But it lacked any features of a mollusk. They were defeated. The world's leading experts, who could identify a species from a single bone fragment, were faced with a creature they could not place in any known animal phylum on Earth. It was an outlier, an alien from our own planet's past. After years of fruitless research, Dr. Richardson did something rare in science. Instead of trying to force the creature into an ill-fitting classificatory box, he acknowledged its uniqueness. In a scientific paper, he officially named the creature in honor of its discoverer. A name that was both scientific and an expression of wonder. Tullimonstrum gregarium, Tully's common monster. The case was officially opened, and it would haunt the field of paleontology for more than half a century. Once the Tully monster was named and introduced to the scientific world, it was no longer just a strange stone. It became a case file, a 300-million-year-old victim in need of an autopsy. Paleontologists from around the world flocked to the field museum, not with hammers and chisels, but with microscopes, cameras, and the sharpest minds, ready to perform the most detailed post-mortem possible. Their mission: to analyze every clue, no matter how small, to force this silent victim to reveal its identity. Before they could understand the monster, they had to understand the miracle that preserved it. Mason Creek was not just a coal mine, it was a perfectly sealed crime scene, 307 million years ago. This was a vast tropical estuary, where meandering rivers emptied into a warm, shallow sea. This environment was teeming with life, but also with death. When a creature like the Tully monster died, its soft body would quickly sink into the fine mud at the bottom. And this is where the miracle happened. Instead of being decomposed by bacteria, its body was rapidly encased in a layer of mud, rich in the mineral siderite, iron carbonate. Over time, these minerals precipitated around the organism, forming a hard siderite nodule, a natural coffin. This coffin protected the soft body from decay, flattening it and preserving a perfect three-dimensional impression of its form, from the tiniest teeth to the faint traces of internal organs. When Francis Tully split that nodule, he wasn't just finding a fossil. He was opening a coffin that had been sealed for 300 million years. With this understanding of the extraordinary preservation process, the scientists began their detailed examination. The first clue was the body. It was torpedo-shaped, elongated, seemingly designed for agile movement in water. On the surface of many specimens, they could see faint transverse lines, suggesting a segmented structure. This was a crucial detail. Segmentation is a characteristic of many animal groups, from annelid worms to arthropods like shrimp and insects. Was this a sign that the Tully monster belonged to one of these groups? The question was noted in the file. Next, they turned their attention to the proboscis. This was a long, slender, and seemingly flexible structure, extending from the front of the body. It was not part of the head, but more like a separate appendage. At the end of the proboscis was a pincer-like structure with a joint, and inside was a row of teeth, usually 8 small, sharp, and conical. This was clearly a tool. But a tool for what? Was it a hunting weapon used to grasp small, slippery prey? Or was it a probing tool used to rummage through the soft mud at the bottom for food? A mouth at the end of a long proboscis is an extremely unusual arrangement in the animal kingdom, and it only deepened the mystery. But if the proboscis was strange, The eye bar was utterly absurd. Scientists stared at this structure with disbelief. The two eyes, so perfectly preserved that even the melanin pigment granules could be seen, were not located on the head in the usual way. They were at the ends of a rigid horizontal bar that stuck out from the sides of the body, like two headlights on a bumper. This structure had never been seen in any other creature, living or extinct. It raised countless evolutionary questions. What benefit did such an arrangement provide? Did it allow for stereoscopic vision to accurately judge distance? Or did it provide a nearly 360-degree field of view, helping it to both spot prey in front and watch for predators from behind? Whatever the answer, this eye bar was a testament to the fact that evolution can sometimes produce completely alien design solutions. Experiments that seem to follow no rules. Finally, the scientists looked at the most important and also the most controversial clue: the faint traces of internal organs. Inside the torpedo-shaped body, they could see a few structures preserved as darker stains. The most notable was a straight, sometimes pale, line running the length of the body. This was the crux of the entire case. What was this line? There were two main possibilities, and each would place the Tully Monster on a completely different branch of the tree of life. The first possibility was that it was simply the gut, the creature's digestive tract. If so, this would strengthen the hypothesis that the Tully Monster was an invertebrate, possibly a worm, mollusk, or something similar. But there was a second, much more audacious possibility. Could that line be a notochord? The notochord is a flexible, cartilaginous rod that is the precursor to the spinal column and is the defining characteristic of all vertebrates and their close relatives, chordates. If the Tully Monster had a notochord, however primitive, then it was not a worm or a slug. It would be a member of our own lineage. It would be a vertebrate. This clue was too faint to be certain. It was like a smudged fingerprint at a crime scene, open to multiple interpretations. And it was this ambiguity that would fuel a scientific debate that would last for 50 years. After the autopsy, the scientists began to reconstruct the crime scene, the world in which the Tully Monster had lived 307 million years ago, during the Carboniferous period. It was not a barren world. It was a world of giant swamp forests with towering ferns, of giant insects flitting through the oxygen-rich air. The Mazon Creek estuary was a vibrant ecosystem. To better understand the life of the Tully Monster, the scientists looked at the other witnesses, the fossils found in the same rock layer. There were delicate jellyfish, exquisite ghost shrimp, ancient horseshoe crabs, and even early sharks like Bandringa. The presence of these creatures helped the scientists paint a vivid picture. The Tully Monster swam in these warm, brackish waters, alongside creatures we can still recognize today. Yet it was a complete stranger among them. Was it a predator or prey? With its pincer-like mouth, it probably hunted small shrimp or worms. But with its soft body and no protective shell, it could also easily have become a meal for the early sharks. The examination was complete. The case file was filled with astonishing details. The scientists knew its shape, its structure, and the world it had lived in. But the most fundamental question, the question Francis Tully had asked on that fateful summer day, remained larger and more challenging than ever. What was it? Where did it belong on the tree of life? With its contradictory clues, a worm-like body, an arthropod-like mouth, and a possible internal structure of a chordate, the Tully Monster had become the Rorschach test of paleontology. Scientists looked at the same fossil but saw completely different things. The case was full of evidence, but no single theory could explain it all. The battle of hypotheses was about to begin. In the years following Francis Tully's discovery, the Field Museum became a battlefield of ideas. Paleontologists from around the world arrived, bringing their expertise and their own biases, all hoping to be the first to crack the Tully case. The room containing the Mazon Creek fossil collection was no longer a quiet storage space. It had transformed into a jury room where each expert presented a different indictment, based on the same set of evidence. The first and longest war was waged within Camp Invertebrate. For the vast majority of scientists at the time, this was an almost obvious conclusion. The creature was soft-bodied, had no bones, and was found in a Lagerstätte, famous for its invertebrate fossils. The question was not if it was an invertebrate, but what kind, and this is where the Civil War began. The first, and perhaps most popular, theory in the early years was the mollusk hypothesis. Foster looked at the soft, unsegmented body of the Tully Monster and saw the silhouette of a bizarre sea slug or a distant relative of the octopus and nautilus. They argued that the long proboscis could be a type of siphon or a modified radula-like structure. They imagined a creature like a misshapen sea slug, crawling on the estuary floor, using its proboscis to search for food. It was a plausible image, an attempt to put the monster into a familiar box. But the box didn't fit. If it was a mollusk, why did it have faint segmentation lines on its body? And most importantly, no mollusk, living or extinct, has a rigid eye bar sticking out from its sides. This theory, while popular, had to ignore the strangest features of the victim. This paved the way for another faction within the invertebrate camp, the arthropod camp. These scientists focused on different clues. They looked at the segmentation lines and argued that it was undeniable proof of a segmented body, the defining characteristic of arthropods. They looked at the jointed proboscis and saw similarities to the appendages of shrimp or insects. To them, the Tully monster was not a slug, but a bizarre evolutionary experiment of the arthropod lineage. They compared it to other strange creatures from the Cambrian explosion, like Opabinia with its 5 eyes and pincer-tipped proboscis, or Anomalocaris, the apex predator with 2 spiny appendages. Perhaps, they argued, Tully is just a late survivor of those weird body plans. But this theory also had fatal flaws. The most important characteristic of arthropods is a chitinous exoskeleton. The Tully monster had absolutely no trace of an exoskeleton. Its body was soft and flexible. Once again, to believe this theory, one had to ignore a crucial piece of evidence. As the major theories proved unsatisfactory, some scientists turned to a simpler explanation, an attempt to apply Occam's razor. This was the worm hypothesis. Perhaps, they said, we are overthinking this. Perhaps the Tully monster is simply a bizarre predatory worm. The long, soft, segmented body it all fits. The proboscis could be an aversible pharynx used to catch prey, like in modern priapulid worms. This was the least glamorous explanation, but it was also the weakest. It completely failed to explain the eye bar, the tail fins, or the complex structure of the mouth. It was like describing a car by only saying it has 4 wheels, ignoring the rest of the machine. Decades passed, the 60s, 70s, 80s, then the 90s. New generations of paleontologists came and went. The debates continued at conferences, in scientific papers, and in the hallways of museums. But no single theory could win a consensus. The Tully monster had defeated them all. It became a famous problematicum, a problematic fossil. In the scientific classification system, it was placed in a sad category called inserte sedis, of uncertain placement. This is a polite Latin term for saying, we have no idea what this is. The Tully monster had become an orphan of the Tree of Life, a homeless wanderer in the animal kingdom. It became a stone Rorschach test. One scientist looked at it and saw a slug. Another looked at the same stone and saw a shrimp. A third saw a worm. The fossil didn't change, but human interpretation was endless. It became a legend in the field, a puzzle that professors would often give to their students, not to find an answer, but to teach them about the limits of knowledge and the humility required before the complexity of the past. But throughout the noisy decades of the invertebrate debate, there was another voice. A small voice, almost drowned out. It was the voice of Camp Vertebrate. From the very beginning, a few scientists, looking at that faint straight line running along the creature's body, felt an unusual pull. They were not distracted by the strange proboscis or the absurd eye bar. They were obsessed with that simple line. Everyone is looking at the flashy things, one of them might have thought. But the real secret lies here, in the humblest detail. They proposed a theory that was considered heretical at the time. That line was not a gut. It was a notochord. If that were true, then everything would change. The Tully monster would not be a worm, a slug, or a shrimp. It would be a chordate, a member of the very phylum that includes fish, amphibians, reptiles, birds, mammals, and humans. It would be our distant cousin. This was a revolutionary idea, but it ran into a major problem: the lack of convincing evidence. The line was too faint, too ambiguous. The invertebrate camp counterattacked fiercely. "That could be anything," they argued. "It could be a flattened gut. It could be a collapsed major blood vessel. It could just be a fold created during the fossilization process. You cannot build such a grand theory on a shadow." And they were right. The evidence was too weak. The vertebrate hypothesis remained a minority theory, a lone voice in the wilderness of debate. It was noted, but not taken seriously by the majority. The main battle continued to be fought between the factions of the invertebrate camp, and so, the case reached a deadlock. Decades passed without a breakthrough. The Tully monster remained a mystery, an insult to the neat classification system of science. It lay there in the museum drawer, silent and defiant, a reminder that there are creatures so strange they seem to have come from another universe. The 20th century ended. A new millennium began. The Tully monster case file was covered in a thick layer of dust. It seemed this mystery would never be solved, but science never stands still. While the paleontologists were arguing, a technological revolution was quietly taking place in other fields. New tools were being invented. Tools capable of seeing things the human eye could not. Tools that could analyze the faintest chemical traces. A new generation of detectives was about to emerge, armed with weapons that the generation of Richardson and Foster could never have dreamed of. The 50-year-old cold case was about to be reopened. The deadlock was about to be broken. And the answer, when it came, would shake the world of paleontology. The new millennium arrived, bringing with it a powerful wave of technology that transformed every field of human life. And paleontology was no exception. While the debates over the Tully monster continued in academic hallways, repeating the same old arguments, in laboratories around the world, new tools were being perfected. These tools could analyze matter at the microscopic level, seeing the chemical ghosts that soft tissues leave behind after hundreds of millions of years. The 50-year-old cold case was about to face a forensic revolution. This revolution was led by a new generation of detectives. They didn't just rely on the external shape of the fossil. They could read the stories hidden in its chemical composition. And one of the leaders of this generation was Victoria McCoy. As a graduate student at Yale University, McCoy was fascinated by the Tully monster. She was not burdened by the decades-long debates. She looked at it with fresh eyes, and more importantly, she had a new weapon in her hands. That weapon was the scanning electron microscope, or SEM. To understand the power of this tool, imagine it as more than just a regular microscope. It doesn't just magnify an image. An SEM fires a beam of electrons at the surface of the fossil. The way these electrons interact with the material reveals not only its microscopic structure, but also the precise chemical composition of every tiny point. It's like a forensic tool from a CSI series that can scan a scene and not just see a stain, but analyze whether it's blood, ink, or some rare compound. For a soft-bodied fossil like the Tully monster, this was a game-changing tool. It could find the chemical traces of long-decomposed organs, the ghosts of melanin in the eyes, or the traces of cartilage in a primitive skeletal structure. McCoy and her team, including her advisor, Professor Derek Briggs, decided to conduct the most comprehensive and definitive investigation ever undertaken on the Tully monster. They didn't just look at a few of the best specimens. They systematically gathered and analyzed over 200 Tully monster fossils from the collections of the Field Museum and elsewhere. It was a monumental task, requiring thousands of hours of meticulous work. They placed each fossil under the SEM, scanning every millimeter, mapping its structures and chemical compositions, creating a massive and unprecedentedly detailed dataset. They began by re-examining the most crucial clue, the one that had caused the biggest debate: that faint, straight line running along the body. For decades, it had been just a shadow. something open to interpretation. But under the electron beam of the SEM, that shadow began to speak. Chemical analysis revealed that this line had a different chemical composition from the surrounding tissues. It contained traces of proteins and keratin arranged in an organized fashion, consistent with the structure of a notochord, the flexible, cartilaginous rod that is the precursor to the spine. This was no longer a speculation based on shape. This was chemical evidence. The vertebrate hypothesis, once a lone voice, now had its first piece of physical proof. But that was just the beginning. With this lead, McCoy's team began to search for other corroborating evidence, features that a primitive vertebrate must have. And they found them, one after another, like a detective finding a string of consecutive clues at a crime scene. They looked at the faint transverse lines on the body, which the invertebrate camp had claimed as proof of segmentation. But under detailed analysis, they saw that these lines were not separate segments, but traces of V-shaped muscle blocks, known as myomeres. This V-shaped muscle structure is a classic feature of fish and other early vertebrates, used to create the undulating motion of swimming. Next, they looked at the head region of the creature. Near the eye bar, they discovered faint, pouch-like structures. Analysis showed these were gill pouches, a respiratory feature of aquatic chordates. They even found evidence of a brain. By mapping the indentations and chemical traces at the front end, they reconstructed a tripartite, or three-part, brain, another characteristic feature of vertebrates. Piece by piece, the puzzle fell into place. The notochord, the V-shaped muscle blocks, the gill pouches, the three-part brain, they all pointed in one direction. The Tully Monster was not a worm, not a slug, not a shrimp. It was one of us. It was a vertebrate. In March 2016, after years of hard work, McCoy's team was ready to announce their verdict. They published their findings in one of the most prestigious and rigorous scientific journals in the world, Nature. This was not an ordinary paper. It was a bombshell announcement. Their conclusion was clear and definitive. Tullimonstrum gregarium is a vertebrate, a jawless fish, closely related to modern lampreys. They had reconstructed its image completely. The Tully Monster was a small predator, swimming in the estuaries, using its stalked eyes to scan for prey, and then lunging forward, using its flexible proboscis to grasp the victim with its toothed mouth. It was a bizarre evolutionary design, a unique experiment, but it belonged firmly on the vertebrate branch. The reaction from the scientific world was almost a collective sigh of relief. Major news outlets around the world, from the New York Times to the BBC, reported on the event. Mystery of the Tully Monster finally solved. The headlines blared. The paleontological community seemed to have found peace. After more than 50 years of wandering in the wilderness of classification, the orphan of the Tree of Life finally had a home. The half-century-old case seemed to be closed. Scientists celebrated. Museums updated their displays. The Tully Monster had been brought home. But in science, no case is ever truly closed forever. There are always other detectives who look at the same set of evidence and see a completely different story. And just as the excitement over the 2016 discovery was settling down, another group of scientists stood up, ready to overturn the verdict. They believed the jury had made a mistake, and they had new evidence in their hands, evidence hidden in the very eyes of the monster. The battle for the soul of the Tully Monster was just beginning. The paleontological world celebrated. The headlines had been written. The textbooks were ready to be updated. The Tully Monster, the prodigal son of the Tree of Life, had finally been brought home, welcomed into the embrace of the vertebrate family. The case that had spanned more than 50 years seemed to have reached a satisfying conclusion. But in science, no case is ever truly closed forever. There are always other detectives, those not convinced by a simple solution, who look at the same evidence and see flaws, contradictions. And in the Tully case, the opposition did not stay silent for long. Just 1 year after the sensational announcement by the McCoy team, in 2017, Camp Invertebrate counterattacked, and they did so with astonishing force. Leading this rebuttal was Lauren Salin, a paleontologist from the University of Pennsylvania. along with an international team of researchers. They were not stubborn conservatives clinging to old ideas. They were serious scientists who felt that the 2016 verdict had been reached too hastily, based on a misinterpretation of the evidence. They decided to reopen the case file and conduct their own counter-investigation. They didn't have flashy tools like a synchrotron scanner, but they had something more powerful: a meticulous and skeptical re-examination of every single clue that had been presented. They began to dismantle the case built by the McCoy team, piece by piece. First, they targeted the smoking gun, the notochord. Salin's team argued that the structure identified as a notochord in the Tully Monster looked nothing like the true notochords found in other jawless fish from the same Mason Creek ecosystem. Real notochords, even when fossilized, show microscopic structures, distinct tissue layers, but the line in the Tully Monster was just a uniform stain, with no internal structure. It could be anything, they argued. It could be a flattened gut, or even a trace created as the body decomposed and collapsed. To call it a notochord based on its external shape is a leap of faith, not a scientific conclusion. Next, they examined the V-shaped muscle blocks. The countercamp pointed out that these lines were extremely faint and inconsistent across all specimens. They could simply be folds in the creature's skin, as it was flattened during fossilization. To interpret them as complex muscle blocks was, in their view, an overinterpretation. But the most powerful blow, the decisive evidence that overturned the verdict, came from the creature's most bizarre feature: its eyes. Salin's team and their collaborators, particularly experts on eye fossilization, decided to conduct an extremely detailed forensic examination of the Tully Monster's eyes. They knew that inside the eyes of most animals, there are microscopic structures called melanosomes, organelles that contain the pigment melanin, which creates color. And miraculously, these melanosomes can sometimes be preserved in fossils. More importantly, scientists had discovered a rule. The shape and chemical composition of melanosomes differ distinctly between vertebrates and invertebrates. The eyes of vertebrates, like fish and us, tend to have small spherical or elliptical melanosomes. In contrast, the eyes of invertebrate mollusks, like squid and octopus, have larger, cucumber-shaped melanosomes. This difference is a highly reliable biological fingerprint. Using a scanning electron microscope, the research team magnified the fossilized eyes of the Tully Monster thousands of times. And what they found was a shock. The melanosomes inside the Tully Monster's eyes were not spherical at all. They were large and shaped exactly like cucumbers. They were a perfect match for the fingerprint of mollusks like squid. But they didn't stop there. They also conducted a chemical analysis of these melanosomes. They found that the ratio of zinc to copper in the pigment granules of the Tully Monster was completely different from that of vertebrates, but was nearly identical to that of modern squids. This was irrefutable evidence. Based on the structure and chemistry of its eyes, the Tully Monster could not be a vertebrate. It had to be an invertebrate. Their research was published, also in a prestigious journal, directly challenging and refuting the 2016 conclusion. The paleontological community was once again thrown into chaos. The verdict that seemed so final was now overturned. The battle for the soul of the Tully Monster erupted again, this time even more fiercely and contentiously than before. On one side, McCoy's team still defended their conclusion, arguing that the evidence for the notochord and muscle blocks was too strong to be ignored. They argued that perhaps the Tully Monster was an exception, a primitive vertebrate that had evolved a different type of eye. On the other side, Salin's team argued that the evidence from the eyes was too fundamental and clear. The eyes don't lie, they might have said. They argued that the structures identified as a notochord and muscle blocks were simply misinterpretations. The scientific community was split. Some paleontologists supported one side, some supported the other. Others, perhaps the wisest, simply shook their heads and admitted that the mystery was not solved. The Tully Monster, after a brief welcome into the home of the vertebrates, was once again cast out, returning to its status as a homeless wanderer on the tree of life. This unexpected twist not only made the case more complex, it also exposed a profound truth about the nature of science. It showed that science is not a straight path to the truth. It is a messy, contentious process, with steps forward, steps back, and intellectual showdowns. New technology can bring an answer, but deeper analysis or even newer technology can overthrow that answer. The investigation had returned to square one, but on a completely different level. Now, we not only have questions about its external shape, we have conflicting microscopic and chemical data. The case had become more baffling than ever, and the Tully Monster, silent in its stone slab, seemed to be smiling at the confusion of the intelligent bipedal creatures who had been trying to decipher it for 7 decades. The investigation has returned to square one, but it is not the same as before. The Tully Monster case has been on a dramatic journey. From the accidental discovery by an amateur, through decades of deadlock and ambiguity, to a technological breakthrough that seemed to solve everything, and finally, to a surprising twist. A powerful counter-evidence that brought the mystery back. Today, the status of the Tully Monster is more controversial than ever. The paleontological community is once again divided. Is it a primitive vertebrate with anomalous eyes? Or is it an invertebrate mollusk that independently evolved a notochord-like structure? Both possibilities challenge what we thought we knew about evolution. The debate is still raging in scientific journals and at conferences. The Tully Monster is, once again, a homeless wanderer on the tree of life. And perhaps, that is exactly where it belongs. But perhaps, finding the final answer is not the most important legacy of this story. The true legacy of the Tully Monster lies not in what it is, but in the journey we have taken to try and understand it. The story of the Tully Monster is a perfect example of how science really works. Science is not a textbook filled with immutable facts. It is a messy, passionate, and sometimes brutal process. It is a battle of ideas, where evidence is presented, challenged, and reinterpreted. It is not a straight road to the truth, but a winding path with advances, retreats, and dead ends. New technology can bring an answer, but it can also raise even more baffling questions. The truth is not found in a single eureka moment, but is built from the fragments of debates and failures. Furthermore, the Tully Monster is a symbol of the boundless and sometimes utterly absurd creativity of evolution. It is a reminder that the tree of life does not always grow in neat, understandable branches. Sometimes it produces strange experiments, unique body designs that seem to follow no rules. It was a failed experiment that was once brilliantly successful for a moment in Earth's history. A testament that life can exist in forms we cannot imagine, and then vanish without a descendant. Let us return to the final image. A small, gray fossil lying silent under the museum lights. It is not just a stone. It is a 300-million-year-old puzzle. It is a reminder that the past is a truly alien planet, and that even after centuries of study, the Earth still holds secrets that can challenge everything we think we know about the story of life. The case remains open, and perhaps that is the most wonderful thing of all. Thank you for taking the time to listen and to watch today's story. And of course, as always, a massive thank you to everyone who supports the Science Stories channel. Whether you just watch the videos, leave a comment with your own theory, or share this story with others, I truly appreciate that contribution. The world is full of mysteries waiting to be explored. Always keep an open mind and never stop questioning. I wish you all the best, and I'll see you in the next episode.